Hello, everyone, and welcome to this edition of UCalgary's webinar series, where we explore the innovative technologies that can fuel change in Alberta's energy systems. I'm Deborah Yedlin, and I'll be your moderator for today. If you've participated in one of our previous webinars, welcome back. And to all our viewers that have not joined us before, thank you for being here today. It's going to be a very interesting session. We began this webinar series at the onset of the pandemic to inform and support our community by connecting them with COVID-related research and resources. And since then, we have expanded our focus to include a wider variety of webinar topics, but our purpose is still the same: to share and discuss knowledge and insight from UCalgary experts with our community. Together, we can use research and facts to take on the challenges that face us. Today's webinar is part of special programming for UCalgary Innovation Week, which we are celebrating in conjunction with Innovation Week YYC, Canadian Innovation Week, and Global Entrepreneurship Week. Innovation Week is an opportunity to reflect our aspirations to our community and share some of the work that makes the university a leader in both energy research and in fostering innovation. Philanthropy supports this work. It powers the research, initiatives, and innovation that will define our future. For example, in 2016, the University of Calgary was awarded $75 million from the Canada First Research Excellence Fund to implement an interdisciplinary research initiative focused on lowering the carbon footprint of unconventional oil and natural gas resource development. The timing of this webinar, given the tabling by the federal government today of its net zero emissions legislation, which includes a clean fuel standard, is fortuitous. Today's panelist, Joule Bergerson, leads one of the research projects focused on finding ways to achieve negative emissions, which will be critical to meeting the goals of the clean fuel standard. Dr. Bergerson is Associate Professor in the Schulich School of Engineering at UCalgary and Canada Research Chair in Energy Technology Assessment. On the innovation side, the new Life Sciences Innovation Hub at the university has been made possible thanks in part to an incredibly generous contribution from Shell Canada Limited under the leadership of Michael Crothers, who is also here today as a panelist. Mr. Crothers is Vice President of Canada Integrated Gas in Royal Dutch Shell and Shell Canada President and Country Chair. After we hear from Dr. Bergerson and Mr. Crothers, we will open the discussion for questions from the audience. Please submit your questions or comments at any time by using the Q&A feature on the bottom of your screen. Our panelists will answer as many questions as time allows, and I suspect we're going to have a lot of questions. A recording of today's webinar will be available, and we'll email you a link as soon as it's online. Before we begin, I'd like to acknowledge that we're recording this webinar on the traditional territories of the people of the Treaty 7 region in southern Alberta, which includes the Blackfoot Confederacy, as comprising the Siksika, Piikani, and Kainai First Nations, as well as the Tsuut'ina First Nation and the Stoney Nakoda, including the Chiniki, Bearspaw, and Wesley First Nations. The city of Calgary is also home to Métis Nation of Alberta, Region 3. I'm now going to turn it over to our first panelist, Dr. Bergerson. Over to you.
Great, thank you very much, Deborah. I'm excited to be here today to be part of the dialogue in Alberta about innovation generally, and specifically in the area of opportunities for negative emissions, which I see as a critical piece in ensuring that Alberta remains competitive in a low carbon future. And I'm going to set the stage with some background, some definitions to get you thinking about this and coming to a common place of terminology, and hopefully get you interested in asking and posing some of those questions. The first thing I'll say is that by negative, that doesn't actually mean that it's a bad thing. We're actually saying negative means that you're below the bar in terms of reducing emissions. And I'll give you the specific examples, but just saying that our attempt at talking about these negative emission technologies is actually to achieve emission reductions overall. So if we go to the next slide, I'll jump right to my key messages. And the first one is that negative emission technologies are needed if we want to meet our climate goals. This is both at a global level as well as an individual company level, that for all of these that we're considering, we really need to think about the role that negative emissions can and should play within that emission reduction trajectory. The other point that I want to make today is that I see this as a huge point of opportunity for Alberta to leverage our assets, our knowledge, our expertise in developing and implementing negative emission technologies. So next slide, please. So getting into the definitions then, there are three necessary characteristics for negative emission technologies. The first is that we need to actually remove carbon dioxide from the atmosphere, ocean, or biosphere. We then need to sequester that CO2 permanently. And then lastly, we need to remove more CO2 than we emit as part of that process. So those are the key determinants of whether or not you actually have achieved a negative emission technology versus a mitigation technology. Next slide. Okay, this is a really complicated figure, so you'll just have to give me a minute to explain the details here. This is a standard way in which we look at emission trajectory over time. So on the y-axis is CO2 emissions in gigatons of CO2 emitted per year, and this is at a global scale. On the x-axis is time. So we're starting in 2008, and then we have a planned trajectory for what we consider to be business as usual. And so this is what we expect our global emissions to be on an annual basis if we don't have aggressive climate reduction targets in place and act on those. If we want to meet the climate targets, so here they're showing the target of stopping climate from global warming from below 2 degrees. So we want to keep that warming below the 2-degree level. Then we need to bend the curve from that black business as usual at the top down to that blue curve and trajectory. You can see that trajectory needs to hit a carbon neutral line, and to hit that below 2-degree target, you need to hit that at around 2075. And so we need to be neutral by that time. One of the biggest ways to do that is that green wedge there, which is the mitigated CO2 emissions. Those are the technologies and procedures and strategies that we implement to reduce the emissions from where we are today. So those are things like energy efficiency, implementing new technologies, say putting carbon capture and sequestration on a power plant, for example. All of those things are going to reduce our emissions below where our trajectory would be if we hadn't implemented those. And that is what's needed, and we need a lot of those, and we need to be aggressive about deploying those. But to actually reach neutral, we have to consider the fact that some of the emissions that we have in our economy today are going to be really difficult to actually reduce down to zero. And that's where the role for negative emission technologies come in. And so those are the blue areas below that zero mark. So those are emissions that actually reduce more CO2, remove more CO2 from the atmosphere than they emit. And they can actually help balance out some of the more difficult to get at emissions within our current system. And so we're talking on the order of gigatons per year, but that is really why negative emissions need to be part of the suite of technologies and strategies that we deploy in order to actually achieve that carbon neutrality that we put forward, and then into the future going into a negative emission trajectory. So next slide, please. So these are some of the examples of carbon removal from the atmosphere. And on the left-hand side are more of the nature-based solutions, so afforestation, soil carbon sequestration, biochar, those kinds of things. And Michael will be speaking to some of those in just a minute. In the center section, we have technologies that are related to carbon capture and storage. So geological reservoirs is where you would actually store that carbon dioxide. To the right is enhanced weathering, and then ocean fertilization. Each of these are potential opportunities on the order of gigatons per year that could be delivered through these mechanisms. But all of them also have some challenges and uncertainties associated with them, and they're quite different depending on which technology you're looking at. And so it's really important to think about all of these. I would also say that short of the ocean fertilization, Alberta can really play a role and actually deploy technologies all the way across that. So ocean's not there, but the rest of these technologies are possibilities for implementation in Alberta. And I would say I'm going to focus on that middle section because I think that's where we actually might even have a strategic advantage in terms of developing and deploying these technologies, given our understanding and use of geological reservoirs. And if we could do that in the near term at scale and actually deploy these negative emission technologies, we could actually be a world leader in this space. Next slide, please. So just giving you some concrete examples. And so if we are actually taking fossil carbon out of the ground to power a power plant, for example, but we actually capture the CO2 from that power plant and inject it into a reservoir for storage, that's considered to be carbon capture and storage. And that is a net positive greenhouse gas emissions, because we're not capturing every single CO2 molecule across the supply chain, but it is a significant mitigation technology. So if you can advance the slide. It would fit within that green wedge of the trajectory, right? It's a carbon reducing technology. It's the kind of technologies that we need within our system to reduce our emissions. Next slide. Bioenergy with carbon capture and storage, that is where you could actually lead to a net negative emission technology. So if you could click the next slide. You'll see that if you can actually get the carbon in the biomass from the atmosphere, you can actually then use that for energy purposes and then capture the CO2 as you combust that bio-based product, store it in a reservoir, and then the end-to-end net effect of that is a negative emission technology. So that would fit within that blue wedge within the diagram that we were just looking at. So next slide, please. This next one is getting a little bit complicated, but this is enhanced oil recovery, where we're injecting CO2 into a depleted oil reservoir to produce oil, but you also get this benefit of storing CO2 in the ground. If you do that with carbon that comes from an industrial source, you're actually doing better than if you got it from a naturally occurring source of CO2. And so this, again, could be a mitigation technology. So next. Yep, so again, it's part of the green wedge. It's a mitigation technology if you're doing better than we're doing today in our current instance of deploying this technology. Next slide, please. This last one is another concept that I and several of my colleagues at the University of Calgary are working on, which is combining something that we do regularly today and have done for decades, which is the enhanced oil recovery. But instead of getting our carbon from a naturally occurring reservoir, we could actually get it out of the air, right, using direct air capture technology. And if we could take it out of the atmosphere and use that CO2 to produce more oil from a depleted oil well, and change the way that we operate that reservoir such that we try to maximize both the oil production as well as the CO2, making those two changes to a currently operating system could lead us to that negative emission technology. So if you click to the next. This has the potential to become negative. We haven't deployed this to date at commercial scale, looking at the technologies in this place, in this combination. And so we have to prove that out. There's still uncertainties associated with this technology, but this hybrid combination of infrastructure and expertise combined with a new technology has real potential. It's one example of the types of hybrid solutions that I would say we need to be thinking about in Alberta. And it has this added benefit of generating a profit from the additional oil that you're getting out without having to establish more infrastructure. And so it has potential. We need to investigate it further, but it's not just an academic exercise. So we see that Oxy Petroleum has actually invested in a carbon capture technology to deploy in their Permian Basin fields to actually supply the CO2 that they need for those floods. So we're seeing industry interested in investing. They will help to test out this technology and demonstrate whether or not negative emissions can actually be achieved. But the fact that it has potential to be negative, I think it warrants more investigation from our side. Next slide, please. And so just going back to my key messages then, negative emissions technologies are needed to meet our climate goals. I hope I've convinced you of that. The next piece is that there are opportunities for Alberta. And having part of the discussion today focused on ways in which Alberta could engage in developing and deploying these technologies would be helpful. So thank you very much for your attention. My last slide, if you can skip ahead to, is just to let you know that we do have a follow-up webinar that's coming out. And we'll be diving more deeply into each of the individual technologies that are sort of available for net negative technologies. And so my colleague Sean McLean will be the moderator for that session, and we've got experts from around the world that will be contributing to that dialogue. So save the date, December 1st, and we will be in touch with more details of how you can register for that webinar if you're interested. Thanks very much for your time.
Thank you, Dr. Bergerson. And now I'd like to ask Michael Crothers to share his presentation. Michael, the floor is yours.
Thank you, Deborah. And thanks to you and the University of Calgary for inviting me along today with Dr. Bergerson to talk about something that I think is really exciting. I'm a Calgary kid, and so it's cool to be on this kind of a platform with the University of Calgary and talking about opportunities here in Alberta. And having been in different parts of the world working for Shell, I can tell you that there's no more exciting and dynamic place in the world in terms of looking at these innovations than right here in Alberta and in Canada. So it's really exciting. Kristen, the next slide. I will not go through this with you, but it's simply to say that because I'm talking about the future, there's some uncertainties, and you shouldn't be running out and making investments based on what I'm saying. And you can go to our website if you want more information. The next one talks about our high-level strategy, which we've had now for several years. And it's really driven by this purpose that you see on the left-hand side of the slide there. Powering progress together by providing more and cleaner energy solutions. That's been what's driving our strategy for the last 5 years. Of course, we have elements that you'll recognize. You know, we want to be a world-class investment case, which means we have to consider our investors and make sure that we're creating value for everyone. But more importantly, we're really trying to leverage ourselves towards lower carbon technologies. And this is actually, I can't express how transformational it has been within Shell the last few years and continues to be. To be able to thrive in the energy transition, we need to position our whole portfolio and our whole way of working and thinking to a net zero future by 2050. And that means radical reshaping of our portfolio. And you can see us shifting from heavy oil over time towards LNG and integrated gas towards renewables. And that is continuing at a very high pace and with a substantial amount of investment that of recent years has been around 2 billion per year, and that is going to be growing towards 4 to 5 billion per year. The last strategic ambition, which is really key, is that we want to do our part. We want to do our part in terms of managing the impact on climate and meeting the Paris Accord goals. And that means staying in step with society, understanding what our customers need, what our investors are asking about, and being able to adapt our business plan on the fly to deal with those changing realities. So very exciting, challenging place to play, but this is our commitment that we're going to stay in concert with society and do our part. Next slide. So here a bit more about our climate ambition, which is to be a net zero company by 2050, to help, if we can, achieve not only less than 2 degrees, but an ambition of 1.5 degrees C limit on global warming, and be a net zero energy business in all facets. So our commitment not only affects our so-called Scope 1 and Scope 2 emissions, the emissions from producing our product and the emissions that come from energy we use to produce products, but also from our products themselves. So it really involves doing 3 key things. Reducing emissions to net zero from our production processes. So how can we get our production to be net zero? And that's actually fairly challenging, but doable. Reducing the carbon intensity of our product. And that's the huge portfolio shift that I was mentioning. So you can see us acquiring at a high pace a whole collection of technologies, investing in technologies and deploying technologies. So we're one of the world's largest biofuel producers. We have several biofuels projects, including a couple of ones in Canada, one called Forage Hydrocarbons in Ontario, and a couple of others that are close to announceability. We have invested in solar through our affiliate Silicon Ranch. We have invested in huge offshore wind farms. We're investing heavily in hydrogen in a small way in Canada with a couple of hydrogen stations in Vancouver, but looking at how we can leverage our Scotford site here in Alberta to be what we call an energy hub, taking renewable power through to hydrogen, either blue, meaning with carbon capture, or green from electrolysis, linking that to hydrogenated vegetable oil and into a whole new value chain, which will be very low carbon. And this is happening across Shell at scale, while we also invest in other clean fuel technologies. So that's the second part of it. The third part of it's probably the most challenging. And that's because about 80 to 85% of the emissions that come from our total business come from when customers use our product. So if we're going to be net zero, we have to work with customers to help them by sector decarbonize. So that's going to be a big challenge for the aviation sector in particular, for shipping. But for example, in shipping, we've been able to start transitioning ships from bunker fuel to LNG. We just had sea trials on, as far as we can tell, the world's first hydrogen-powered ship, and we think that hydrogen has a big role to play in heavy transport, like shipping, like transit, and also heavy goods vehicles. So exciting things happening, but we're determined to work closely with customers to help them achieve this goal, and as part of our overall commitment to climate. Next slide, please. So here's a picture that picks up on what Dr. Bergerson was talking about on her continuum. Part of that continuum is looking at there's no single climate solution. We have to use a variety of tools to achieve our goals, and this slide is trying to depict some of those. Be that cleaner burning natural gas instead of oil-derived products, be that solar or wind, but also using nature to help sequester carbon and help customers now to compensate for emissions that are currently unavoidable when you are using a car, for example, or a truck that's burning gasoline or diesel fuel. And as this schematic is intending to illustrate, when CO2 emissions are hard to avoid, they can be compensated through our own portfolio using global nature-based solutions projects, where we've invested. Our current scale of investment is about $200 million this year and next in accredited projects, accredited by third parties, that demonstrate that the carbon is being captured and not released back into the atmosphere. So those types of investments include wetlands, reforestation, afforestation, as Dr. Bergerson mentioned, and grasslands. And we have an interesting project coming up here in the West using grasslands also as an opportunity. We announced last week that we're working with the Schulich national government on a project in their territory to invest in reforestation. They've had devastating fires, and in fact, earlier today we had a really great celebration ceremony with the Schulich chiefs on Zoom. We couldn't get there in person, obviously, given COVID, but they're really excited. I'm delighted to be working with them, and it's an opportunity to bring together a lot of aligned interests on conservation, on creating a long-term resource for future generations, and with the potential of creating carbon credits. And we're hoping that over time, the government's net zero ambition framework announced today will allow portable carbon credits across the country and allow us to really optimize the best solutions for reducing our emissions, but also in an affordable way for customers, and taking advantage of the regional strengths that are within each part of Canada with their own energy mix. And I mentioned working with customers, and one of the things that we just started also last week was a drive carbon neutral. So you're able to, Shell will work with customers. We're offering initially free, but over time, 2 cents a liter, we will acquire accredited carbon offsets. We're using the Darkwoods project here in Canada to buy those offsets, but also international, to be able to allow people to compensate for the emissions, like some people have been able to do with airlines for a few years. Maybe on to the next slide. Dr. Bergerson mentioned the opportunity of using bioenergy in one of the opportunities to get you into that kind of blue zone, where you actually are able to find feedstock that are related to biomaterials, and that reduces then the overall carbon intensity of the product to potentially a net zero or less than zero. So we're looking at converting waste wood, straw into biofuels, and you can then reduce the emissions even further by coupling that with technology for carbon capture. And of course, our Quest project, which I'll talk about momentarily, up in Edmonton, has been doing that for over 5 years very successfully. And we are sitting on this massive basal aquifer here in Alberta that we know can store these the CO2 safely, as it stored the natural gas and oil for millions of years. So we actually have a really strong opportunity here as well. And our first attempt at this is actually in the US, where you have a bioethanol plant. And I mentioned Scotford and the ability to convert it into a hub. And this is part of the thinking of Scotford, being able to take natural feedstocks, waste vegetable oils or canola oils or other vegetable oils, initially co-process them, but eventually actually convert them with green hydrogen or blue hydrogen into hydrogenated fuels, biofuels, coupled with carbon capture, that allow us to get to a very, very low carbon footprint. My last slide is just, again, building on some of the comments that Dr. Bergerson was making about the importance of carbon capture. And I can't emphasize enough how pivotal this technology is going to be here in Canada. And we have this massive oil sands resource here in the province. It's been continued to be driven down in terms of its emission intensity by all the different companies involved in that sector. And the opportunity for us, as I think the world's roughly number 4th biggest oil producer, is keep reducing the carbon intensity of that oil using carbon capture, such that we can actually be the last molecule standing, if you will, because it will be the most sustainable barrel. It'll be the lowest carbon intensity barrel, and we can use that opportunity to reduce emissions globally. A similar analog would be with natural gas through our export of LNG, because the carbon intensity of that natural gas that we're part of as part of the LNG Canada project is actually only half the global average. But for carbon capture, this is a depiction of what happens at our plant in the background. We can capture the CO2 coming off our hydrogen plants using an amine, which is a proprietary Shell technology. And then you can concentrate that and put it safely back into the reservoir. This has worked extremely well for us. We've been able to share this technology fully openly. It's part of an investment that was made by the governments of Canada, Alberta, and the Athabasca Oil Sands Partners, which are now CNRL, Chevron, and Shell. And it really works. And it's been very highly reliable and delivered a lot of value. There's several other projects in the world that Shell's been involved in that build on this technology. In particular, the Northern Lights project up in Norway with Equinor. We also have other experiences with Gorgon in Australia, and of course with Boundary Dam in Saskatchewan. So part of the concept here is we need to trial these technologies. We need to find the opportunity to get them into operation. In our view, the next iteration of Quest will be at least a third cheaper in capital and operating costs by virtue of what we've learned. It's key that we're able to continue to test and innovate with these technologies at scale, drive the cost down, and then be able to use them as part of this journey to net zero emissions. So I'll leave it there, and we'll get back to your questions. Thanks.
Thank you so much, Michael and Dr. Bergerson. I'm going to start with one question, and as I expected, there's a whole bunch that have already shown up. But I wanted to touch on this, on the net zero legislation that was tabled today by the federal government and the clean fuel standard component as it potentially affects the competitiveness of the energy sector. Is this also a way for the government to regulate Scope 3 emissions? Because what we see is the onus on industry more than on the consumer to deal with this, the emissions challenge. Your thoughts on what this means for Canada's energy sector going forward and how we meet that challenge?
That's for me, Deborah.
It's for you, Michael, and then I'm going to ask Joule to weigh in because I think some of her research dovetails with this, finding a solution to this.
Sure. Well, I mean, starting with clean fuel standard, it's 30 megatons out of about 219, I think, megatons that the government of Canada is trying to reduce because we have this overall requirement around Paris. So it's not going to be the solution for all of our emissions in terms of managing. There's a lot of other components like building efficiency, steel making, other elements that have to happen within that. But within that opportunity, yes, I mean, there is an intent which Shell supports, and we talked about reducing the carbon intensity of transportation fuels. And you can do that by converting it much more towards biomass, by converting biomass into fuel. We talked about that, but also by coupling carbon capture with existing technologies to reduce the emissions from refineries. So those are mature technologies now. Yes, there's some of the biofuels that are somewhat still in development phase, but with some support of government working together with industry, we can de-risk that technology and then scale it up in the same way that we've done with oil sands over the last few decades. And we continue to do both with natural gas and with oil sands in Canada. The net zero framework, I think, is as much an opportunity as a threat. And I know, sitting here in Alberta, worried about the future of the oil and gas sector,
Mm-hmm.
it feels like we're always under pressure. At the same time, we do have to be part of this change. And Shell's view is we need to participate. We need to actually partner with governments and with customers and with our investors who expect this of us. And those are challenging things to try to balance. But because we have this, I think, an amazing capability to innovate that we've demonstrated over many decades here, and we have the talented people be able to do it, I'm confident that we can find pathways. There'll be a variety of pathways. They'll be different by region. Some will involve taking hydropower to hydrogen if you're in BC or Quebec. Some will involve carbon capture because we're sitting on this amazing, as I mentioned, basal aquifer here in Alberta. Some of them will involve biomass because we have enormous biomass in every part of the country. And we have the opportunity to use nature as well as a part of the solution. Now, I'm not saying that nature is the whole solution. It's only part of it. But various scientists and observers have said that if we want to get to the fastest way to get to the Paris ambition is to deploy existing technologies like carbon capture, use the capacity that nature already has, and create an opportunity, as I mentioned earlier, to encourage people to be investing to create carbon credits that can be used in the most efficient way, portably across the country, such that we can have something that actually ends up affordable for consumers in the end. Because we have to recognize that even though we have this ambition of transforming our energy system over the next 20, 30 years, we will still have, depending on your study and your analysis, and we have our own scenarios, 50, 60% hydrocarbon derived energy by 2050.
Yeah.
So the key thing is, how do we keep that lower carbon intensity while we make the shift to renewables in the same time frame? Thanks.
Joule, I know some of this work, some of this fits right into what the research you're doing. What are your thoughts on, the clean fuel standards and what kind of barriers are there in order to achieve the goals that the federal government's going to lay out?
Right. Yeah. So my research work is focused on systems analysis of energy technologies. And when you were talking about the clean fuel standard in terms of scope 3 emissions, I think about it more about connecting our energy system. So these are steps in the supply chain that are all very connected. And so looking for opportunities to reduce emissions, I think it's actually really important to look from that connected perspective, that we can get the biggest bang for our buck in terms of where is it cheapest to get the reductions and where can we do that quickly. If it doesn't make sense to do it upstream, maybe there's opportunities to do it downstream. And looking across that, I think as a goal for a regulation, I think that's really helpful. I think the devil is in the details and how do you get there. I think one of the things I've seen with this standard is the data that's available in the public domain is lacking in terms of being able to make those connections in really clear ways. And actually, the group that I work with on this, we were talking about actually adding a fourth criteria to the negative emissions. And that is actually that you need to verify and demonstrate in a transparent fashion that you're actually achieving reductions. If you don't do that, stakeholders will not be buying into this as an opportunity. And so this is, maybe not the best way, but one way in which you can actually demonstrate those emission reductions are occurring.
Yeah, no, that's absolutely true. People say it's great that companies make these commitments, but how are they going to measure it, and what steps are they going to take to get there?
I just might build on that comment.
Sure.
I think it's an
Yep.
important one because it was really the core of what I heard from the federal government today, which was they are building an accountability mechanism into this structure of their pathway to net zero, being every 2.5 years within their 5-year plan, they're coming back and making a public report. There's an external advisory body that's going to be giving them an annual report card. And then there's a, as part of that is an action plan to respond to the gaps that are being seen. So I think to Dr. Bergerson's point, there's a bit of accountability being built into that construct.
We were asking a question about how companies shifting away from fossil fuel production could be ceding that market to countries that are also oil producers that may be not as committed to ESG metrics and climate challenges. And so, does it make sense to do that, or does it make sense to really work as an industry to make sure that the net zero ambitions are achieved, rather than abandon the production of fossil fuels entirely as a way to transition a business model? Curious as to your thoughts on that.
Yeah, it's a really important concept. And as I said earlier, because Canada has the potential to produce lower carbon intensity hydrocarbons, we should be the last molecules used, if you will,
right.
globally. And part of enabling that is something that we've been talking about for a while called Article 6 within the Paris Accord framework, which would
right.
give recognition that the countries that are using this lower carbon intensity product are actually getting a unique value from that, and that's able to be credited towards the country that's producing that lower carbon intensity hydrocarbon, some sort of credit towards their Paris goals. Now, that's been very difficult to land internationally, but what
right.
Canada could do is do some bilateral arrangements with specific countries that we have good trading relationships with. And I'll give you a high-level example, but again, the LNG coming from LNG Canada with our 4 Asian partners and Shell is going to be going into North Asian economies like China, and it's
right.
going to be displacing coal. And that's an enormous opportunity for global reduction of CO2 emissions. We need to think about this as a borderless issue. The climate is global. This is global warming, not just warming in Calgary or in Beijing. And but I also think there's an opportunity while we drive the emissions down, we need to recognize that over time we're going to be using less and less hydrocarbons. And the opportunity in that for us in Canada is we do have many other resources we're blessed with, including, as I mentioned, biomass. We can produce hydrogen at scale. We have carbon capture. We can export those technologies and those products as well, and kind of ride the transition and make sure that we continue to do the right thing for the environment, but also maintain prosperity within our society.
Joule, do you have any thoughts to contribute?
Yeah, I think all of the above is kind of my perspective on this, is that
right.
what we're using today has to get better, and we also need to be cognizant of this carbon leakage that could occur. And this is an issue not just with oil and gas, it's with all the products where we're in different locations putting different levels of stringency in terms of reductions. But I would also say that I think the biggest movement towards actually committing to reductions has been the ESG component of this. The investing community has really made this front and center. I would hope that they would be savvy enough to recognize that climate is one metric, economics is another, and other factors should also be taken into account in terms of secure supply, other things. But not to say that we don't have to be cognizant of that, and the more transparent we are about the sources, their impacts, and the progress of reducing impacts means that I think that many will stay on the table in terms of opportunities.
So, Michael, you mentioned that climate change has no boundaries. Emissions it's a global issue, and yet when we hear the statistic that the oil sands account for 1/10 of 1% of global emissions. Is there a sense that we're spending a lot of money to solve a problem that if we stop production from the oil sands today, it wouldn't make any difference at all to the emissions on the planet? so how do you square that circle in terms of what we have to spend in terms of intellectual capital, financial capital to address this issue when we really aren't the biggest offenders on the planet when it comes to energy production and use?
Well, for Shell, we can't duck our responsibility. That's our view. We have to do our part. And the carbon intensity of oil sands is coming down dramatically, and we'll soon be at, or maybe even slightly below, that of conventional crude. That's where we need to go to be able to have that societal license to operate that I mentioned earlier. We're going to have to demonstrate to Canadians in the world that we can actually continue to drive those emissions down, and we're not going to be just ignoring the contribution that those products make to global warming. So I don't think you have the right to just say it doesn't apply to you. You're not going to be taking responsibility. And to what Dr. Bergerson was saying, our investors expect that of us. Our customers expect that of us. And so that's why you see Shell very dramatically pushing our portfolio towards lower carbon intensity options. We want to be a viable company in 2050. And we want to make sure that we're not seen to just be sitting on the sidelines here. We need to be part of the solution.
So, Dr. Bergerson, we've talked a little bit about the energy landscape changing. How do we? But we need all the molecules. We need the molecules. We need the electrons. And so, how do we sort of shift? What we're undergoing, you could probably characterize it as a transformation of our energy systems. What do you think we need to do in order to make sure that we include all those molecules and we shift the infrastructure to accommodate all the different sources of energy that we're going to use as a planet? Because we can't just use one, we're going to need everything. What do we need to think about?
Yeah, I think that, in the academic sort of view of things, it would be great if we could sit down and plan everything out and choose the most optimized but in reality, what we're going to see is that each region is going to transition differently based on the resources they have access to, their policies, their ability to actually have a hand in that transition rather than it unfolding unto itself. I think that we're seeing dramatic changes, things like photovoltaic costs coming down faster than anyone had predicted. And so we see that in terms of any sort of competitor to the system we have in Alberta, we need to be aware of and planning for. None of these things are going to be able to access all of our existing infrastructure. And so we need to be planning for the infrastructure requirements. I think that is a particular challenge given the diversity of things that we have on the table right now. But I can't see that happening at a national or global level. It's going to happen at local and regional levels that planning has to occur. And so each of our systems are going to look quite different in 20 years, depending on what region you're in.
Michael, you talked about the last molecule coming from Alberta, and I'm just wondering, there's a question here. It says, is it realistic for Alberta to hope that the oil sands will be among the candidates for the last barrel in terms of emissions intensity? How much CO2 capture do you think is needed in order to bring the oil sands into par with that per barrel emissions on a global basis?
That's a really good question. I haven't calculated that. That'd be a good question for a modeler at the UC to look at.
There you go.
But within Shell, for our own decarbonization journey, we think we need 6 or 7 quests in the next kind of 10, 15 years, talking about really large scale continued deployment. And with our scenario work that we do with MIT, you're talking hundreds of CCS projects globally to be able to leverage quickly that opportunity to get CO2 out of the atmosphere from our existing production of energy. The technology is mature. There's half a dozen existing projects moving along, and like I said, Shell's part of 4 or 5 of those. And it's just a matter of now getting on with it. You see, the U.S. has put in place some fiscal help through what they call the 45Q.
Yep.
Yeah. And that's really unlocked a lot of opportunity to provide an economic incentive. I think we've been talking about that here in Canada as well, to try to help get that cost per ton down a bit, give an incentive, help to recover that initial capital cost. But like I said, this technology that we've developed, we share openly with anyone. It's being utilized, it works, and it's certainly scalable. So I think looking at oil sands, I'm not sure how many more Quest we're going to need. Quest is 1 million tons per annum, but I would guess multiples of that are going to be required to achieve the goal you mentioned for oil sands here. On the gas side, let's not forget the other part of our resource base is natural gas, and we're producing 12 to 14 billion cubic feet a day. We're going to convert 4 of that out of the Western Canadian Basin into LNG and ship it off to those Asian economies I talked about that are burning coal. That is a transformational change, not only for emissions, but also for air quality and human health. Mm-hmm. And that, again, is something that we should be feeling proud about as Canadians. How does that come about? Well, because of electrifying our gas fields, our production facilities using BC hydropower, having a hybrid LNG facility that uses a lot of hydropower as well, low emission through methane controls at every point in the process, and low CO2 in the actual natural gas itself. Yeah. It all combined to create this incredibly low carbon intensity natural gas, and customers are asking for it. We've been selling carbon neutral cargoes to our big industrial customers, and over time, this can become a competitive advantage for Canada in terms of what customers are going to be asking for and willing to pay for.
And how does that turn into a competitive advantage?
It's because as so many countries get on board with the goals of climate change, and there's a price on carbon, and there's a price on carbon in many countries now, having lower carbon intensity product will actually give you some credit, because you're not going to be paying as much for the emissions related to that product over time. And if you can start selling, I mentioned biofuels, or convert some of your industry and energy consumption over to hydrogen, for example, then you can avoid having to pay carbon taxes.
Right. I'm curious, it seems to me that, we talked a lot about carbon capture and storage about 10 years ago. And then it fell off the table, so to speak, because people said, well, it's a great idea, but it's really expensive. And in the last couple of years, the conversation has changed dramatically about carbon capture and storage and utilization being very important to addressing the climate issues. So what flipped the switch from carbon capture and storage being, makes sense, not scalable, maybe a little too expensive, to all of a sudden being everything top of mind for everybody in this world? Dr. Bergerson.
Yeah, sure. So having watched this actually evolve over time, it sort of has ebbed and flowed, right? So at one point it was the attention, and then it sort of faded, and projects didn't come online as they were anticipated to, the Quest project being an exception to that. I think projects like Quest have given some confidence to stakeholders that this actually can work and can work safely, and can actually result in emission reductions. I think there's also this natural shift globally in terms of, including ESG, but also, just in general in terms of climate reductions. And almost every energy system model you can look at requires some amount of carbon capture and storage in it to achieve the goals. So it almost, even the most optimistic of the energy system projections requires some form of CCS in there. And so I think that the inevitability of and the extreme need for the CCS, I think, is sort of changing people's perspective and having them look at it a second time.
Michael, can you point to where the switch flipped, so to speak? And because like I said, it was off the table, now it's on the table.
I think Dr. Bergerson covered it really well. There's a combination of technical feasibility combined with just pragmatism. That, hey, this is a very, very large scale deployable tool that's become economic, and it has such huge capacity in terms of mitigating climate change now, that it makes so much sense just to go after it. So I think it's partly those two things.
So I'm curious, one of the things that not a lot of people have paid attention to is the Alberta carbon trunk line, and the investment that went into building the carbon trunk line, which is the world's newest and integrated large-scale carbon capture and storage system. That took a long time to build. It was not cheap. We live in a world that is very capital constrained. how do we find a way to finance these kinds of projects that are clearly, as you just both said, have such potential? Where does that come from?
Well, I think it has to come in part through a collaboration with private companies, with governments, and also, with innovators to keep driving the cost down. So I think if we can work together, that's actually a good formula. To me, it's quite a far-sighted piece of infrastructure, and it's a bit like, we invested in railroads, we invested in national, transnational highway and road systems. We invested in airports. We need to invest in the infrastructure of a lower carbon society. And, a carbon trunk line like we have in Alberta is the beginning of a backbone of what could be a very important long-term sustainable opportunity for us. While we continue to and start to expand, and hydrogen is getting a lot of buzz these days, but hydrogen has one of these other enormous opportunities because of the combination of resources we have in Canada to create that low carbon intensity energy infrastructure, which again, we're blessed with the opportunity to be able to develop. And really, but to de-risk that technology, to get on the path like solar was 20 years ago, where you had this expensive panels and didn't make any sense, and then working together with universities, with government, with private sector capital, we actually drop the cost of that dramatically. Something like that could happen also with the likes of hydrogen, and will happen, and is happening already with carbon capture. But people sometimes don't realize that the right conditions have to be there for creating investment. And part of the concern that the industry's had is a lot of uncertainty about where the government's going, what are the underlying fiscal supports going to look like, what are the opportunities to reduce the complexity of our systems here to be able to enable investment. Those are open conversations. You see a lot of determination, I think, to work together to start to overcome some of those. Certainly, we think there can be a lot more that could be done as an industry to improve the climate for investment. But we won't get there by going into our corners and shouting at each other. We have to work together, and we have to include Indigenous partners in this conversation because they have so much access to this resource, and they actually understand the land and the water and the resources in a way that we don't. And if we respect that knowledge and work together, then it sounds a bit motherhoodish, but if we can capture the kind of cooperation we've had in the last 6 or 7 months through the COVID crisis, I think we're going to be almost unstoppable. But if we polarize this debate again, and that there's an energy mix that can't have hydrocarbons in it and must only have this, that we're going to fail. We need to think of this as a mix, as a transition over time, as an ability to work to deploy the technologies that Dr. Bergerson mentioned at pace, but not to be technology specific. We have to allow the market to work along with the innovators to find what's most competitive in each part of the country with its own advantages. Dr. Bergerson?
Yeah, I would just add two things. I think that the Alberta trunk line is a really complicated project, right? So it's got multiple moving parts. It's proving out multiple parts of this process with the fertilizer, the refinery, the pipeline, and then the enhanced oil recovery operations. And so I think that we don't necessarily need to replicate that same thing moving forward. We can learn from that and build things that are maybe simpler and optimized further. I think also if you talk to the people that built it this first time, their second, if they had to build it a second time, they would be a lot faster and it would come in a lot cheaper, right? So that's part of what we need to be doing is actually deploying these things. They're not going to be perfect in their first instance, and then we learn and we build the next one better, and that has to be part of the solution as well.
So this is gonna be my last question because we're going to run out of time, but both of you, if you could talk about the importance of hydrogen and as a fuel and where we're going and what the timeline is for actually being able to use it as consumers in industry for industrial application. This seems to be, again, it's sort of it's the flavor of the day from a fuel perspective. Tell us why it can work and how expensive is it and what it means from an infrastructure perspective. Either of you can take that first and
Well, I can take us first. We're deploying hydrogen now in retail. So we have this for consumers. What works best, as we're learning, is first an industrial anchor customer, be that, thousands of forklifts in the port of Los Angeles, or the refinery we have in Rotterdam, or in Germany. From that, you can scale and connect to mobility, to trucks, to the buses, and so on. We're building a project right now to take offshore wind to green hydrogen to biofuels. And that same kind of thing can be done in Alberta.
So huge potential for Alberta.
Absolutely.
Dr. Bergerson?
Yeah, I think with hydrogen, I think we have to remember that this is an energy carrier, right? So it's like natural gas in terms of it's not the be all and end all by itself, right? You actually have to transform it further into something else. And, and there is just a plethora of options for how you might make use of that hydrogen. I agree that these large scale industrial applications is something that we know a lot about, and we do a lot in Alberta already. So why not start there? You get economies of scale, you get that knowledge of the system. And so there's definitely opportunity there. In terms of growing the use of hydrogen, there are some challenges in terms of long distance transport, those kinds of things, not insurmountable, but there are some questions about how to make that economic. So I think there still are some questions, but it is, there's quite a few viable routes for the use of that hydrogen.
One quick add, and that is around using hydrogen and natural gas as a small complement in the existing natural gas system. That could be where we end up starting, and then, as Dr. Bergerson says, building more of a hydrogen energy system over time.
Well, on that note, I want to thank both of you for your answers to your questions and for bearing with us as we had our little technical glitch. I'm sorry, there were a bunch of questions that disappeared completely, so I apologize to any of the attendees who had put in questions. They disappeared into the ether, so I'm sorry about that. So thanks again for being part of this conversation and part of UCalgary Innovation Week. And as I mentioned earlier, everyone who signed up today will get an email with a link to view this session on demand. And if you enjoyed the discussion today, I encourage you to visit ucalgary.ca/community, where you'll find more webinars, podcasts, and stories on topics that matter to you. And as Dr. Bergerson said, there's another webinar on the 1st of December about negative emissions. Hopefully you'll be able to join us for that. Thanks everyone. Have a good day.
Thank you.